So, welcome again to the new course, welcome again to the new lecture of the course, properties of materials. So, let us just briefly see what we did in the last class. So, in the last class what we did was we explored the phenomena of slip, which is a mechanism of plastic deformation. So, slip is basically slipping of a bunch of atoms against another bunch of atoms across a slip plane along a direction. So, the combination of this slip plane and direction, this gives rise to what we call a slip system. So, slip, we looked at the various characteristics of slip plane. So, the slip plane is generally a close packed plane for solids which are close packed or plane with highest planar density of atoms. So, basically if you have a FCC or HCP system, then you have a close packed plane, but if you do not have HCP or SCP, if you have BCC, simple cubic, etc., then you will have plane with the highest density. And then you have a slip direction, and this direction is again a closed packed direction or if you do not have closed packed direction, then direction with highest linear density. So, essentially if you consider the touching sphere model, then in every solid you will have by and large a close packed direction, and this close packed direction will lie within the slip plane, and the slip direction UVW lies in the slip plane HKL, implying that UVW dot HKL is equal to 0. That means UH plus VK plus LW is equal to 0. So, the dot product of the two is equal to 0. So, basically this is what a slip plane is, slip system definition will be. Now, so what we did was we worked out how to calculate the planar density. We took one example and then we also looked at the linear density along a direction, and then we also did FCC slip systems which are 12. So, 4 111 type planes. So, 111 bar 111, 1 bar 11 and 11 bar 1. Each of these will have 3 directions of let us say 110 type. So, now if you have 110 type direction, what it means is that you have to have indices which have dot product equal to 0. So, this will become 4 into 3, this will give you 12 slip systems. You can do the similar exercise for BCC. Now, for BCC things are a little different. So, this is a BCC system. In BCC you have atoms here, 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 and there is one at the center. So, in BCC what happens is that this direction 111, so the direction 111, this direction which connects this atom, this atom, this atom. So, 111 direction is a closed packed direction with highest linear density. So, if you take for example this particular plane, so in this particular plane let us say this is 110 plane. So, you will have one atom sitting here another atom here, another atom here, and this will constitute the 1 1 1 direction. So, this will be 1 1 1 type direction. Okay. So, basically if you have, so if direction is 1 1 1 type, the plane is 1 1 0 type, or rather you can write these. Then such that your dot product is equal to 0. So, but 1 1 1 direction does not only lie in 1 1 0 plane, it can also lie in other planes. So, for example, so this 1 1 1 direction can have, so these are, so the combinations of 1 1 1. So, if you look at 1 1 1 dot h k l, that is equal to 0, basically h plus k plus l should be equal to 0, okay, for 1 1 1. So, which means you have various combinations. First combination could be h plus k is equal to minus l, another combination could be h is equal to minus k and l is equal to 0, or one of these is equal to 0. So, basically if you work out the combinations, you will see that you have 1 1 0 type of planes. So, you can have 1 1 0 meaning you can have 1 1 0, you can have bar 1 1 0, you can have 1 0 bar 1, you can have 0 bar 1 1. So, some of these direction planes 1 1 0 bar 1 1 0, and then we can also have 0 1 1 1 0 1. So, these 6 planes will have these directions. So, 1 1 0 for instance can have bar 1 1 1 and 1 bar 1 1. Similarly, bar 1 1 0 can have 1 1 1 or bar 1 bar 1 bar 1. So, you can keep doing the maths and you will see that it will have 6 planes into 2 directions. So, 6 is the planes and each plane will have 2 directions, because if you look at this 1 1 0 plane, this is the 1 1 0 plane, this is the central atom, this is the corner atom, you have one atom here. So, you can have one direction as this direction and another direction could be this direction. Both of them are 1 1 0 type of direction. So, both of them we can say are 1 1 0 type, sorry 1 1 1 type of directions. So, you have 6 planes, each plane containing 2 directions, which means you will have 12 slip systems. But this is only for 1 1 0 plane. So, 1 1 1 direction can also make a dot product with other planes. For example, if you have for example 1 1 2 kind of plane, then we can have HKL could be 1 1 bar 2 for this direction. You can also have 1 2 3. So, HKL in this case could be 1 2 bar 3. This is for 1 1 1 direction, but if you have multiple cases of 1 1 1 direction, you will have different combinations. So, if you do the maths for number of non-parallel, so these are, you can say 6 non-parallel planes, okay, 6 distinct planes. So, number of non-parallel planes for 1 1 2 will be 12. So, you can work out 12 combinations. So, the way you will go is you write 1 1 2, then 1 2 1, 2 1 1, then bar 1 1 2, 1 bar 1 2, 1 1 bar 2, and so on and so forth. You keep writing this and then you will have 12 combinations of non-parallel planes. So, and so on. Okay. So, each of these planes will contain one direction, all right. So, they contain only one direction. So, number of directions in them is equal to only 1. So, total slip systems of 112, 111 type will be equal to 12. So, we worked out 12 earlier. So, we had 12 for this, 12 for this, and then you can also have 1 2 3 plane. So, for 1 2 3 plane again you can work out various combinations. So, you can have 1 2 3, 3 2 1, 3 1 2 and so on and so forth, then you put the minus dices. So, you will work out total of 24 planes. So, 24 of 1 2 3 planes which are non-parallel multiplied by each plane containing one direction. So, one direction, one distinct direction, this will give you total number of 24 slip systems. So, total slip systems in BCC will be, first one will be 110, 111, this is 12. Second is 112, 111, this is 12. Third is 123 into 111, this is 24. So, total of 48 slip systems in BCC. The only difference is in BCC none of these planes is close packed, they are the planes with high atomic density. So, none of these planes are close packed, they are the planes which happen to contain, but they contain closed packed direction in them. So, these are all close packed directions. But they contain close packed direction 111. So, total of 48 as we said slip systems. Okay. So, you can do this, you can make a view graph and see it yourself. So, make a cube for instance. So, this is your atom, one at the center somewhere here. Now, 110 plane is this is 110 plane. So, this is the first plane 110, right. Let us say if this is x, y, this is z. If you want to make 112 kind of planes, then we have 1 1 2. So, 112 plane would be the plane which would be this plane, and this plane contains this direction. So, you can say this is the direction. So, 112 goes through the central atom and there will be a direction which will cut through it. So, this will be 112 plane. Similarly, we can have, so 112 dot, you can find out UVW, that is equal to 0, and so U plus V plus 2W is equal to 0, and then you can do the maths yourself. And so we are saying that the direction is 111 type. Okay. So, which means U and V have to be minus 1 and W has to be 1, so that it is equal to 0. So, it is going to be bar 1, one direction, one direction. So, you can denote bar 1, 1, which will pass through this. Another plane is 1 1 2 3 plane. So, 1 2 3 will be 1 2 and 3. So, this will be the plane. and you can just cut across this plane. So, there will be one direction lying through this as well. So, 1 2 3 plane will give you a direction which is again bar 1 bar 1 1 or 1 1 bar 1. So, this will be the way in which you can determine the number of slip systems. So, total number of slip systems is 48 in BCC, but none of them are closed packed planes. They do contain closed packed directions in them though. Now, let us look at HCP. HCP system, as we know, is given as this kind of structure. Okay. So, you have one atom here, another atom here, another atom here, another atom here, and then one at the center. Okay. And then okay. Now, in this case, and of course, you will have two atoms somewhere in between 1, 2 and 3 like this. So, these are at C is equal to half, these are at C is equal to 1 and this is C is equal to 0. So, in HCP the closest packed plane is this plane, this is the closest packed plane whose indices are 0 0 0 1 or 0 0 1. So, this plane is the closest packed plane. If this is the closest packed plane, the directions which are close. So, if you just now bloat it, this is how it is going to look like. So, this is the closed packed plane. In this case, there are only 3 closed packed directions. One is this, second is that, and third is this. So, 1, 2, and 3 on this. So, these are the 3 closed packed directions, and this is closed packed plane. So, basically the directions which are, so if 0 0 0 1 plane is the closed packed plane, the directions which lie in them are of 1 1 bar 2 0 type. These are closed packed directions. So, how many of them are there? There are 3 of them. So, there are 3 of these directions, 1 of this plane. So, slip systems will be 3 into 1, total of 3 slip systems. So, number of slip systems in HCP will be 3 if you consider the closed packed directions, closed packed plane and closed packed directions, but there are other planes as well which contain these closed packed directions. So, for instance, this plane can contain this direction. So, all these planes, they will contain this direction, all right. So, they will also contain these. So, likewise you can form various solutions. So, total number of possible slip systems which contain these closed packed directions could be up to 12 in FCC, but out of those 2, 3 are the most preferable, others are sort of secondary slip systems. So, essentially if you now tabulate this information, so we have a FCC structure, we have HCP. So, for BCC we see that the slip plane, so if you write slip plane, number of non-parallel planes, slip directions per plane, and then number of slip systems. Okay. So, for FCC we know that the plane is, so we can just maybe write it a little lower. So, this is FCC. So, for FCC we know that the plane is 1 1 1 and the direction is 1 bar 1 0 or 1 1 0 type of direction. So, each plane contains 3 directions. So, there are slip plane, I should have written one column for slip direction, though slip direction. So, let me just move it here. So, this is 1 bar 1 0. Number of planes 1 1 1 type planes are 4. Number of non slip directions per plane is 3 and this will make it 12. Okay. And then we have BCC. In BCC we have 3 combinations. One is, so first one is slip plane could be 1 1 0, second is 1 2 1 1 2, let us say, let us go in the order, and third is 1 2 3, and the directions could be 1 1 bar 1, or so in this case it would be bar 1 1 1, in this case it would be 1 1 bar 1, in this case it would be 1 1 bar 1. So, number of non-parallel planes we can say is 6, 12 and 24 for 3 of them. Number of directions they contain is 12, 1, 1. So, this will give you 12 slip systems, this will give you 12, this will give you 24. So, total of you can say is 48 slip systems in BCC, whereas in HCP, let us use a different color now. Okay. In HCP we have planes which are possible is 0 0 1, which is only one plane, then you have 1 0 bar 1 0 plane, and then you have bar 1 1. So, these are, so essentially you have this plane and you also have the plane which is this plane, all right. So, if you consider all these planes, these 3 planes, they contain the directions 1 1 bar 2 0, they also contain the direction 1 1 bar 2 0, and they also contain the direction 1 1 bar 2 0. There are 3 one plane of this type, 3 of 1 0 bar 1 0 type, and 6 of 1 0 bar 1 1 type. They contain, so the first one contains 3 of these directions and these contain only 1 and 1. So, number of slip systems is 3. So, basically we can say A, B, C, D, and this would be basically C into D. So, it is 3 and 6. So, this will be total of 12 slip systems. So, this is how you derive slip systems in case of these solids. You can also work out the solids, for example, in case of solids like NaCl. NaCl is HCP, but the slip system FCC, sorry, and but its slip systems are not same as what you see in case of metals, because in this case the slip plane is 1 1 0 and slip direction is 1 1 0, and this gives you total of 6 slip systems. So, that is because of FCC is structured, but it is not necessarily a closed packed solid. Okay. So, this is what we have done in this lecture. We have worked out the slip systems in these different materials. In FCC we have 12 slip systems consisting of 1 1 1 planes which can carry 1 1 0 type of closed packed directions. BCC has 48 slip systems, HCP has 12 slip systems. Now, out of these the most favorable slip systems are those which in materials which have closed packed planes. So, FCC, although it has 12 slip systems, all of those slip systems consist of closed packed directions lying in closed packed planes, and that is why they are very favorable slip systems. We will do the phenomena of slip in more details in the next few lectures after this. Thank you.